All right, so in this problem, this is another impulse equals change in momentum problem. It says Carol S. was applying her makeup when she drove into South's busy parking lot last Friday morning, unaware that Lisa Ford was stopped in her lane 30 feet ahead. Kara rear-ended Lisa's rented Taurus. Kara's 1,300-kilogram car was moving at 11 meters per second and stopped in 0.14 seconds. So if you look at the problem, the questions are determine the momentum change of Kara's car, determine the impulse experienced by Kara's car, determine the magnitude experienced by Kara's car. Everything has to do with Kara. Nothing has to do with Lisa Ford's car. So again, I could probably do this from the perspective of that it's only Kara, so I don't really have to yet use prime to represent before and after collision. Again, that prime is going to be important when we're talking about two objects colliding and we're keeping track of what's happening to both of them. But we're really just looking at her car. We're not obviously Lisa Ford, who was stopped when she gets hit from behind, her car is going to start to move. So some of the momentum is going to be transferred to her. But in this one, it says determine the momentum change of Kara's car. So for part A, I'll use a different color. I don't like that color. So for part A, the momentum change of Kara's car, so we'll do the momentum change. And if you really, since there is a Kara and a Lisa, if you want to put a K for Kara, because, I could have asked another question and asked something about Lisa's car, but we'll just say, so I could do that. Change in momentum of Kara's car. And so that's going to be the mass times the change in velocity of Kara's car. So Kara's car was 1,300 kilograms. And the change in velocity, she was moving at 11 and came to a stop. So what's her change in velocity? Negative 11. So negative 11 meters per second. So in this problem, negative doesn't mean west. Negative means that she came to a stop. So sometimes in the context of the problem, sometimes the negative would be east or west, and sometimes the negative would mean that it's slowing down. In this case, it's slowing down. So the answer for this one came out to be, negative 14,300. Kilogram meters per second. Again, don't forget your units when you're doing these. So that's the change in momentum. Determine the impulse experienced by Kara's car. Well, impulse of Kara's car is going to equal the change in momentum of Kara's car. So there's no work to be done. It's just conceptually you have to understand that they mean the same thing. So it's going to be negative 14,300 kilogram meters per second, or Newton seconds. Usually when you actually solve an impulse problem, it usually means Newton seconds, because impulse is force of impact times time of impact. And that's why they gave me the time, because in part C, it says determine the magnitude of the force experienced by Kara's car. So the relevant formula is that impulse equals force of impact times the time of impact. So I just have to rearrange this to solve for the force of impact. So the force of impact is going to be impulse divided by the time. And you're going to see we're going to actually get the correct units here, because the impulse is negative 14,300 kilogram meters per second, and that's in 0.14 seconds. So in like a 1/7 of a second, the car's coming to a stop. That's pretty quick. The quicker you come to a stop, the greater the force of impact we have. So, and you can see for my units, I'm going to get a kilogram meter per second per second. That's a kilogram meter per second squared. A kilogram meter per second squared is a Newton. So if you solve this, I know it's going to be a negative number, and it's big enough that I wrote it in scientific notation. So it's 1.0 0.02 times 10 to the 5th newtons. Don't forget the negative either, because it was a force to slow it down, not to speed it up. Any questions with that? All right. So now